Hello, this is Mr. Collier, and today we're doing the unit circle and some exact trig ratios using the unit circle. Okay, so for trigonometry, when you want these exact values, you need to know your special triangles. So these two triangles, this is a 45, 45, 90 triangle, or pi over 4 in radians. This one's 60, 30, 90 triangle, and they're always in this ratio. So you can figure out things like, for example, sine 60 equals opposite divided by hypotenuse, which is root 3 over 2, and stuff like that. Okay, so you need to know these trig ratios, and you also need to know a couple of other things that we're going to go over today. Okay, so here's the unit circle, and if you draw a triangle in here, you can see the sine of the angle is just going to be y divided by 1, which is just y. So sine is always equal to the y value on the unit circle. Cosine equals the x value, and of course tangent is opposite divided by adjacent. Tangent equals this. Okay, so we have a couple other ratios. These are the reciprocals of these ratios. So cosecants, and often we say CSC theta equals the reciprocal of sine, and secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay, in other words, 1 over y, 1 over x, and x over y. Okay. So sometimes the triangles will appear in the 4 quadrants, but if it's right on the boundary line, then you kind of have this infinitely thin triangle, and the y value is equal to the sine value. So like sine 90 is going to be 1 because that's equal to the y value. Cosine 90 is equal to 0 because that's equal to the x value. And tangent 90 equals the y value divided by the x value, which is undefined. Okay? So if you have 90 or 180 or 270 or some multiple of 90, or in radians some multiple of pi over 2, then you always get a boundary angle. And your answers are like 1, -1, 0, or undefined. Okay, this is mainly a summary of what we just did, but notice that, like in the 3rd quadrant, the x values and the y values are negative. Okay, so that means that sine is going to be negative, cosine is going to be negative. Tangent, though, tangent is y divided by x, so tangent is positive. So that leads to this diagram right here. So in this quadrant, tangent's positive. In this quadrant, sine is positive because the y value is positive. In this quadrant, only cosine is positive. And in this quadrant here, they're all positive because x and y are positive. Okay? So you can remember it as all stations to central. That shows you that it's ASTC. That tells you whether it's positive or negative. So let's take a look at some examples. And let's take a look at this one first. So let's take a look at where 140 is on the unit circle. 140 is right there. Okay, so if we draw this little triangle here, then this is a 40-degree angle. Okay, and the y value is positive here. That means the answer is positive. But since we drew this 40-degree angle, the ratio is going to be the same as sine 40. Okay, so here's 40 degrees. Okay, the y value here is going to be the same as the y value over there. So these are actually equal. Okay, they're both positive, they're both exactly the same thing, so they're equal. Okay, let's look at cosine. Cosine, similarly, we have 160 degrees there, 20 degrees there. They're the same x value, but one's positive and one's negative. So this one's negative, this one's positive, so obviously the cosine 160 is bigger. Okay, we can say cosine 160 equals negative cosine 20. Okay, this one, let's just figure out what quadrant it's in. So tangent, let's see, all stations to central. 310 is over here. Okay, 50 is here. One's positive, one's negative, so obviously this one's going to be bigger. Let's look at this one right here. We got 15 is here. 195 is here. But sine is negative here, so this is going to be a smaller value. This is going to be negative. So sine 15 is bigger. And over here we have 355 is very, very close to here. And 185 is there. This is positive. This is negative, so the positive one is bigger. And lastly, 110 is a little bit more than 90 degrees. And 290 is directly opposite here. CAST, so they're both negative. And the angle with the x-axis is both the same, it's 70. So you'd have exactly the same triangle, they're both negative, so they're equal to each other. Okay, let's calculate some exact values next. So 135, let's figure out where it is first of all. 135 is here. Okay, that's the angle 135. The angle it makes with the x-axis is 45. And we have all stations to central, so only sine is positive here. So this answer is going to be negative, but it's going to be same as cosine 45 because it makes a 45-degree angle with the x-axis, and you make a 45-degree angle triangle. So you have to remember a special triangle, 1, 1, root 2 for a 45-degree angle. Another way you can say this one is root 2, 2. That's the same proportions. So cosine 45 is adjacent over hypotenuse, so you can say it's root 2 over 2. So this one is negative root 2 over 2. The next one, 240. 240 is here somewhere. It's more than 180, less than 270. It's actually 60 more than 180. Okay, so, and tangent is positive here. So this is going to be exactly the same as tangent 60. So let's draw the other triangle now, the other special triangle. This is 60 and 30, 1, 2, root 3. The hypotenuse is 2, right? Root 3. So tangent of 60 is root 3 over 1, which is just root 3. Okay. Next one, negative. A negative angle means we go clockwise instead of counterclockwise. So negative 45 degrees is right there. Okay, that's negative 45 degrees. Sine is negative in this region. So this is going to be the same as negative sine 45. Because the angle mixed with the x-axis is 45, right? Sine 45 is root 2 over 2. So this is negative root 2 over 2. 480. So 480 is when we go all the way around the circle 360, then an extra 120. Okay, so we go all the way around, and an extra 120. Okay, so this is going to be the same as sine 120. Remember, sine is positive there. So that's going to be the same as sine of the angle it makes with the x-axis, which is 60. And sine 60 is root 3 over 2. So that's root 3 over 2. Cosecant 150. Cosecant is 150. 150 is there. And that makes a 30-degree angle with the x-axis. Cosecant is 1 over sine. Okay, so it's 1 over sine 150. Sine 150 is the same as sine 30. So it's the same as 1 over sine 30. Sine 30 is, let's look at this triangle, opposite divided by hypotenuse is half. So it's 1 over half, or the reciprocal of half, which is 2. Okay, next cotan 240. So that is, 240 is here. It makes a 60-degree angle with the x-axis. CAST, so it's positive here. So this is like 1 over tan 240 is cotan. Tan 240 is the same as tan 60, because it's positive here. Then let's look at the triangle. Tan is root 3. So this is going to be 1 over root 3. And if you want to, you can simplify that by multiplying numerator and denominator by root 3, and you get root 3 over 3. Next, secant is 1 over cosine. By definition, let's figure out where this angle is. It's right over here. It makes a 45-degree angle with the x-axis. CAST, so this is negative. This is going to be the same as 1 over negative cosine 45. Cosine 45, we can use this triangle or this triangle right here. Cosine 45 is 1 over root 2. So this is 1 over negative 1 over root 2. So that's negative root 2. Next, 90. So 90 is a boundary angle. It's right there. This is 0, 1. So it's just equal to the y value. So that is equal to 1. Negative 180 is also a boundary angle. We go clockwise to right here. It's the same as 180 really. And secant is 1 over cosine. So it's 1 over cosine negative 180. The coordinates at this point is negative 1, 0. So the cosine is negative 1. So this equals 1 over negative 1, which equals negative 1. Okay, on to some radians. Let's figure out where that is. Now in radians, this is 0, pi, and this is pi over 2. So this is closer to pi than it is to 0, so it's over in this section. Okay, it's pi over 3 away from pi, so this angle is pi over 3. Okay, cosine is negative here, so this is going to be the same as negative cosine pi over 3. Okay, let me redraw that triangle. In this triangle, pi over 3 is bigger than pi over 6, right? 1, 2, root 3. So cosine pi over 3 is adjacent divided by hypotenuse is half. So that's negative half. Okay, next. This is more than pi. So it's going to be over here. It's pi over 4 more than pi. So the angle it makes with the x-axis is pi over 4. This is the same as 1 over tan 5 pi over 4. And tan 5 pi over 4 is positive here in this quadrant. So this is the same as 1 over tan pi over 4. Let's redraw that triangle. This is 1, 1, root 2, and this is pi over 4. So tangent is 1 over 1, or just 1, right? So the tangent of this is 1, so the cotangent of it is also 1. Okay, last one. This is very close to 2 pi. Okay, 2 pi is right there. If you go all the way around the circle, you get 2 pi. So very close to 2 pi. It makes an angle of pi over 6 with the x-axis. Okay, cosecant is equal to 1 over sine. This is the same as 1 over sine 11 pi over 6. Sine is negative here, so this is going to be equal to 1 over negative sine pi over 6, which is equal to that reference angle right here, pi over 6. So when you look at this triangle, pi over 6 and sine is half. So this is 1 over negative half, which equals negative 2.